In the diagram, ABC is an equilateral triangle. So ABC. So that means 3 equal sides and 3 equal angles, all 60, 60, 60. As is the triangle ADE. So ADE is also an equilateral triangle. So 3 equal sides and the angles all measure 60, 60, 60. F is a point on AD. So here's AD, and here's the point F, such that EF is perpendicular to AD. So such that EF is perpendicular to AD. Part 1. By identifying 2 congruent triangles, so 2 identical triangles, 3 equal angles, 3 equal sides, show that BD is equal to half AB. Consider the right angle triangles ABD, so ABD, and ADC, ADC. Their hypotenuses are equal, so AB is equal to AC. So AB is equal to AC, because remember ABC is an equilateral triangle, so AB must be equal to AC. The side AD is common, so this side is common to ABD and to ADC. Thus the triangles are congruent by RHS. So the R stands for the right angle, so the triangle ABD has a right angle here, and the triangle ADC has a right angle here. So they both have a right angle. They have a common side, and their hypotenuses are also equal. So they're congruent by RHS. The R stands for the right angle. They both have the right angle. The H is the hypotenuse. Their hypotenuses are also equal. And the S is another side, so they have the common side. So we know then that the 3 angles are all equal and the 3 sides are all equal. So since they are congruent, BD must be equal to DC. So BD must be equal to DC. And DC is actually a half of BC. So this is BC, and DC is clearly half of it. And BC is equal to AB. We know the distance from B to C is equal to the distance from A to B, because ABC is an equilateral triangle. So DC is equal to a half BC, which is equal to a half AB. So BD must be equal to a half AB, which is what we were asked to show. Part 2. Use Pythagoras' theorem to show that AD is equal to root 3 over 2 AB. So we're going to apply Pythagoras' theorem, which is c squared equals a squared plus b squared, where c is the longest side, the hypotenuse, to the triangle ABD. So ABD. So we're going to label the longest side, which is the hypotenuse, as C, and the other 2 sides as A and B. So Pythagoras' theorem states that c squared is equal to a squared plus b squared. So we swap the c for ab squared. So we have ab squared, and that's equal to the a, which is ad, so ad squared, plus the b, which is bd, so plus bd squared. So we have ad squared plus bd squared is equal to ab squared. Remember, AB is the hypotenuse. Now we are going to bring the BD squared over the equal sign, and it becomes minus BD squared. But we're actually going to swap BD for half AB, because we proved this in part 1. We got BD to be equal to a half AB. So we swap the BD for half AB, and since we're bringing it over the equal sign, it becomes a minus. So we have AD squared is equal to AB squared minus a half AB squared. Now, a half squared is going to give us a quarter, and AB squared is just AB squared. So we have AD squared is equal to AB squared minus a quarter AB squared. Now this is really 1 AB squared, and 1 minus a quarter is going to be 3 quarters. So we get 3 quarters AB squared. So we have AD squared is equal to 3 quarters AB squared. And then what we have to do is square root both sides. So the square root of AD squared is just AD. The square root of 3 over 4, well, we apply the root to the numerator and the denominator. Root 3 is just root 3. And root 4 is going to be 2. And the square root of AB squared is just going to be AB. So we get AD is equal to root 3 over 2AB, which is what we were asked to show. Part 3. Hence or otherwise show that 3AB is equal to 4EF. So by the same argument, we have AF is equal to a half AD. So AF is really half of AD. So AF is equal to a half AD. And again, using Pythagoras' theorem, which is c squared equals a squared plus b squared, we're going to let the c be AE, the hypotenuse of the triangle AFE. We're going to let the A be EF, and the B be AF. So this is our right angle triangle. So we have AE squared is equal to EF squared plus AF squared. So AE squared is equal to EF squared plus AF squared. Now we know that AE is the same as AD. So AE is equal to AD, because remember this is an equilateral triangle. So AE is equal to AD. So we have AE squared becomes AD squared, EF squared stays the same, and AF squared we swap for a half AD squared, because remember AF squared is equal to a half AD. So AF is half of AD. So then AD squared stays as AD squared, EF squared stays as EF squared, and a half squared is a quarter, and AD squared is AD squared. So now we're going to bring the quarter AD squared over the equal sign. It becomes minus a quarter AD squared. And 1 AD squared minus a quarter AD squared is 3 quarters AD squared. And this is equal to EF squared. And again, as we did with the last part, we square root both sides. So the square root of 3 quarters is root 3 over 2. Square root of AD squared is AD. Square root of EF squared is EF. So we get root 3 over 2 AD is equal to EF. So we have EF is equal to root 3 over 2 AD. We're going to swap the AD for root 3 over 2 AB, which is what we got in part 2. We got AD is equal to root 3 over 2 AB. And then we're going to multiply out the brackets. So root 3 multiplied by root 3. So when we're multiplying fractions, we do top by top, bottom by bottom. So top by top, root 3 by root 3 is 3. And 2 by 2 is 4. So we get 3 over 4 AB. And then we multiply across by 4. EF by 4 is 4EF. And 3 over 4 AB by 4 is 3AB. So we get 4EF is equal to 3AB. And that's what we were asked to show.